Good morning, everyone. So, okay, let me shut the camera, please. Right. Fair it is, no issues. थोड़ा सा एंगल वैसा रहेगा. Am I audible? Can you make it confirm, please? Is it audible? Okay, Shibu. Fair. So let me share the link with others so that they can join. Good morning, Shibu. Just wait a minute. Let me share the link. Good morning, Sundaram. Okay. So today we will take a topic which is important. Every year UPSC asks questions out of that. So that is beta gamma function. Basically what happens is, I guess board का angle is not okay. थोड़ा सा class लेते हैं फिर देखेंगे. चले. So this is lecture 4 for integral calculus. So today's topic is beta and gamma function. ठीक है. One thing I would like to tell you guys here that these are not some like special kind of stuff, but only some special integrations. Okay. So what happens is when I talk about gamma function, basically an integral, please be on the board, 0 to infinity e raised to the power minus x into x raised to the power n minus 1 into dx, where n is positive. Okay. So this special integration is known as the gamma function. Fair. So don't think that will be some special kind of things. Just this kind of special integration. Okay. Chale. So when I talk about gamma function, it is represented by this symbol. Don't confuse with the gamma and factorial. Okay. Factorial is represented by this, right? That is factorial n, right? But this is gamma n. Fair, dear fellows? Chale. So let's have some relations for the gamma function. देखिएगा. Number first, since gamma n can be written, gamma n is given by, okay, so if someone asks what is the definition of gamma function, what will say? Gamma n equals e raised to power minus x, x power n minus 1, 0 to infinity dx, where n is greater than 0, right? Chale. So if I apply here integration by parts, what will happen? So यहां पर चेक करेंगे e raised to the power minus x into x raised to the power n minus 1, okay, minus e raised to the power minus x का इंटीग्रेशन minus e raised power minus x raised power n minus 1 का डिफरेंशिएशन n minus 1 x raised to the power n minus 2 dx, right? Okay. So can you tell me what is e raised power minus infinity? E raised to the power minus infinity is always 0. Okay. And e raised to the power infinity always tends to infinity because e is a number which is greater than 1. Originally it is lying between 2 and 3. So e raised power minus infinity is 0 and x का value 0 लेंगे, so 0 you will get 0 here. Here I got e raised to the power minus x. Okay, just wait a minute. Gamma n is this. So that can be written as n minus 1, 0 to infinity, e raised to the power. This n minus 2, can I manage this as n minus 1 minus 1? Okay, so here in the gamma function, many of the times we will be doing this management, right? Because our standard definition is x ka power n minus 1. So whenever n minus 1 is not looking here, we will try to make that in the form of n minus 1. So what you got, dear fellows, this is gamma n minus 1. Can I write this as gamma n minus 1? Okay, so this is a point to remember, right? This point you will remember. Now, from here itself, we can draw some conclusion. Since gamma n is n minus 1, gamma n minus 1, right? Gamma n minus 1 can be written as n minus 2 into gamma n minus 2. That can be written as n minus 1, n minus 2, n minus 3 dot dot 3, 2, 1, right? So what you can get from here, gamma n is equal to n minus 1 factorial. Factorial has two representations. Either you represent by this or the symbol this. Fair? So one more important point for us is if you want to use what is gamma n in terms of factorial, so gamma 5 will be 4 factorial, gamma 8 will be 7 factorial, right? Chale. One more important point for us here is gamma half is square root of pi by 2. प्लीज पाई बाई टू कहां से आ गया, ठीक है. प्लीज डू रिमेंबर गामा हाफ का वैल्यू इज स्क्वायर रूट ऑफ पाई बाई टू. हाउ इट कम्स बेसिकली, since gamma half can be written as 0 to infinity e raised to the power minus x raised to the power 1 by 2 minus 1 into dx. So this can be written as 0 to infinity e raised to the power minus x into 1 upon root x dx. If you put root x equals to t, so what you will get, gamma half equals, what you will get from there, root x 0, so 0 to infinity square root of minus x t square dt. Okay, square 1 upon 2 root x, that will be 2 dt. Just wait a minute, let me check that value first, right? That is gamma half. Okay, this will be 1 by 2, otherwise this is 2 into dt. So this will be square root of pi by 2. So 2 into square root of pi by 2, that will come out as square root of pi. What I have used here is that we will be doing in convergence of improper integral. 0 to infinity e raised to the power minus x square dx is nothing but square root of pi by 2. This is a standard integration using the Leibniz rule. Through the multiple double integration we prove this. Okay, we will prove later. Fair, dear fellows? So I have used this thing here. Can you observe this? So 2 into square root of pi by 2, that comes as square root of pi. So gamma half ka value we will remember ki that is always square root of pi. This is very important point to remember here. Okay. So if you talk about gamma function, what you need to remember, dear fellows, number first is definition. This is what? Definition. Definition is what? Gamma n is 0 to infinity e raised to power minus x into x raised to power n minus 1 into dx. So using the definition, we have different relations. Number first point is gamma n is nothing but n minus 1 gamma n minus 1. Using this relation, we can get another relation, that is gamma n equals factorial n minus 1. One more important point we have to remember, gamma half is square root of pi. How it is coming out as? By using the definition, and there is one Gaussian integer function, that is e to the power minus x square dx, that is square root of pi by 2. So using this integration here, I got the value of gamma half as square root of pi. Please note down fast. So gamma function mein these many points we have to remember. ख्याल रहे in both of the exams, CSE as well as forest services, they ask questions from this segment. Very important topic for you. Okay, numerical type of questions as well as proof kind of questions are also asked from this chapter. Very important. Hello Shantosh, good morning. No issue. Note down fast. Gamma function I have introduced here. Okay Shivu, chalo. So some persons joined the class later, for them I am repeating. Please listen carefully. Shantosh, everyone, whoever is late, I'm trying to repeat the things. Okay? So today in the lecture 4, we have decided to go for the beta and gamma function. There are two standard integrations basically. Okay. So there is one integration like this. Shantosh, 0 to infinity e raised to power minus x, x raised to power n minus 1. So this integration is a special kind of integration. For that we have given a notation gamma n. This notation is gamma. Don't confuse with gamma and factorial. Factorial is like this, or factorial you can like this. Fair. So gamma n is an integration like this. Fair Santosh? Chale. Now what our duty is to get some interpretations out of this definition, right? So number first I told you you can have the relation gamma n as n minus 1 into gamma n minus 1. So for that, if I go from the definition, if I apply integration by parts here, what I applied? Integration by parts. Okay, dear fellow. So if I apply first into second here, so first into second ka integration and so on, I got the things here x ka power n minus 2. So since our standard definition is in the form n minus 1 kind of, so what I did is n minus 2 ko I have managed to write n minus 1 minus 1. So if I compare this with this definition, this expression will give me gamma n minus 1, because n is here, then gamma n. If n minus 1 is here, then it will be gamma n minus 1. So we have the relation gamma n as n minus 1 into gamma n minus 1, right? Chal. Using this relation, I can get n minus 1 gamma n minus 1. Gamma n minus 1 further can be written like this. Gamma n minus 2 further can be written like this, and so on. So what the relation we have here, gamma n is n minus 1 factorial. So this point to remember, this point to remember. The most important point here is gamma half. We will be using this value throughout the integrations. Okay. So gamma half ka value is square root of pi. How it is so? For that I have used the definition again. Gamma half means n की जगह I will put 1 by 2. So using this substitution, I got the relation like this. What I told you here, this is a Gaussian integer function. For that, this is very standard integration. When we will be doing convergence of improper integral, we will prove that later. But today I have only used this as a result. Okay, Shantosh? So gamma half we got as square root of pi. So till now we have done this much. आराम से कर लेंगे, there is no hurry. Okay. Okay, fair, good. Okay, one more important point we can do here is that will also be used in the beta function to prove very standard questions there. UPSC asks multiple times those questions. So that exam point is, suppose that this is 1. Okay. So putting x equals alpha z in 1, we get, if I put that here, so x is 0, this means z is 0, alpha is some constant, non-zero. Okay. This is infinity, e raised to the power minus alpha into z. इधर में क्या चल रहा है, गामा n. This is into alpha z power n minus 1, right? Into dx will be alpha into dz, right? So what we have, dear fellows, 0 to infinity e raised to the power minus alpha into z raised to the power n minus 1 into dz. This alpha ka power n minus 1, alpha ka power 1. So this comes out as this. So this is a very important relation we will be using later also. Okay. So for gamma function, what the relation we have, dear fellows, if you have here some constant, right, e raised to power minus 2x, so you will have gamma n upon 2 raised to the power n. Okay. इसको लिख लेंगे, प्लीज नोट डाउन इट फास्ट. इसको लिखेंगे, then we will have some examples from gamma function. Okay. Shundram, is it noted? Fair. Now let's have some examples over the gamma function. Okay. So suppose that if you want to integrate or find the value of 0 to infinity e raised to the power minus x into x raised to the power 5 dx, right? अभी देखिएगा, Suppose that you didn't study gamma function. Okay. So if you didn't study gamma function, what you will be trying to do is you will be trying to do by the integration of by parts. So this will be x raised to power minus x 5 minus 0 to infinity minus 0 to infinity plus into 5 into x ka power 4 dx. Again is for minus infinity 0, 0 into this is for 0 is 1. So this comes out as 0. This is 0 to infinity e raised to the power minus x. Again you will be applying integration by parts. So what will happen? E raised to the power minus x minus into 5x ka power 4, 0 to infinity minus 5 into e raised to power minus x into 4 into x cube dx. This will again be 0. So you will have 5 into 4, 0 to infinity. So if you keep on doing, what you will be getting as, right? अब देखिएगा, suppose that if you know y gamma function 0 to infinity e raised to the power x, this can be written as 0 to infinity e raised to the power minus x into x raised to the power 6 minus 1, right? I told you earlier as well here the terms what स्पर्श, तो मैंने कौन सा फर्स्ट फंक्शन लगा दिया है? स्पर्श. एक्सपोनेंशियल सेकंड ही है, सेकंड का ही तो इंटीग्रेशन कर रहा हूं. हाँ स्पर्श. So this will be gamma 6. Gamma 6 is nothing but 5 factorial, right? So if you know the gamma function ka definition, this is just one step answer. Otherwise, suppose that x power 10 happens here, you will end up with 10 iterations. अच्छा okay, okay. Sorry. Thank you, Shpars. चल, कैलकुलेशन वाइज आई हैव डन राइट. यहाँ पे फर्स्ट सेकंड बता रहा था स्पर्श, है ना? चले. So choice is yours from which you want to go. Please note down everyone. Noted? Fair. Chale. So let's have one more question now. Find the value of 0 to infinity e raised to the power minus 5x into x raised to the power 3 by 2 minus 1 into dx. Okay, dear fellows. Ab, what will be the solution? Tell me. Since 0 to infinity e raised to the power minus alpha z into z raised to the power n minus 1 dz equals to, tell me, gamma n upon alpha power n. So 0 to infinity e raised to the power minus 5x x raised to power 3 by 2. 3 by 2 can be written as 5 by 2 minus 1 or not, right? Just managed into dx. So here alpha की जगह 5, right? n की जगह 5 by 2. So this will be gamma 5 by 2 divided by 5 ka power n, right? N is what? 5 by 2. Okay. So 1 upon 5 ka power 5 by 2 into gamma 5 by 2 will be, please be on the board, since gamma n is what? N minus 1, gamma n minus 1. Please observe here. So gamma 5 by 2 will be 3 by 2, gamma 3 by 2, right? So this is 3 by 2. Now gamma 3 by 2 will be opened as 1 by 2, gamma 1 by 2. So this will become 3 by 4 into 5 ka power 5 by 2. Gamma 1 by 2 ka value is square root of pi. So that is your final answer. Fair? Note down, please. If you have any doubt, then please let me know. The next question we can have, note down fast, please. E raised to the power minus x power 4 into x dx. Suppose that you want to calculate this. So let x power 4 is t. So what we will have, let I equals this. So I will be 0 to infinity e raised to the power minus t, right? And this will be dt over 4x square, यहाँ से जाएगा 1 by 4, it will be here 0 to infinity upon t का power half. So what it is, 1 by 4 0 to infinity e raised to the power t power minus 1 by 2 dt. This can be further managed to 0 to infinity t power 1 by 2 minus 1, because minus 1 by 2 can be written as 1 by 2 minus 1 into dt. So what you will have, 1 upon 4 is for n ka value is what? Gamma 1 by 2. So this is 1 upon 4 gamma 1 by 2 ka value square root of pi. So that is your answer. So this is how gamma function ka application you can have. Okay, to have such integrations. So whenever you have integrations of 0 to infinity, exponential and polynomial included, then it is an indication that is a question of gamma function, because by usual integration you may be fell into the trapped. Okay, so please note down. Shantosh, any doubt? Shibu, everyone? Where is Kringshuk today? Kringshuk day. Noted? Okay, Kingshuk day. Thanks. Sure. So let's move now to beta function. Okay. Again. So what I said, this is a special kind of integrations, right? So this is represented by beta mn. Okay? Beta mn. ठीक? And this is nothing but an integration 0 to 1 x raised to the power m minus 1 into 1 minus x raised to the power n minus 1 into dx. Fair? So this is the definition of beta function. Please do remember it. Fine. Now, we will try to establish some relation between beta function and gamma function. So that is the first point here. Relation between beta function and gamma function. So that is nothing but beta mn is gamma n upon gamma m plus n. Fair? That is the relation we have to remember. Fair? Just let me connect the battery, okay? Just wait a minute. Fair. So when you come up with the relation between beta function and gamma function, that relation is defined like this. Second thing that is bit important here, important is this also. Okay. Suppose that this give I 1. What happens if I put substitute x equals to sine square theta, that is dx equals 2 sin theta का cos theta d theta किस में पुट करना है in 1. This is also very famous integrations here, and this substitution will be very famous for this chapter. Okay, चलिए. Okay, चलिए. So what I do is I substitute this here, right? So what you got? Beta mn as when x is 0, sin theta is 0. So theta ka limit will be 0. When x is 1, sin inverse 1 is what? Pi by 2. So this will become pi by 2, right? X ka power m minus 1. So sin square theta means sin 2 into m minus 1 into theta, right? Into 1 minus sin square theta, right? That power n minus 1 into dx, that is 2 sin theta cos theta d theta, right, dear fellows? So this beta mn is nothing but gamma m gamma n upon gamma m plus n here. So this will come out as 2 will be outside, theta ka value 0 to pi by 2 sin 2m minus 2, but this sin theta will become, so 2m minus 1 theta into 1 minus sin square theta is what? Cos square theta. So cos ka power 2n minus 2, 1 cos here. So this you will get as cos ka power 2n minus 1 into theta, right? So one more important relation, very beautiful, that is gamma m, gamma n. This 2 we will write here, that is gamma m plus n equals 0 to pi by 2, obviously theta ka limit, sine raised to the power 2m minus 1 into theta, 2n minus 1 into theta d theta. Please do remember this relation, because while calculating integrals either in the vector calculus or in the integral calculus, that area, volume and all, we will be in the dire need of this formula. Whenever you have some integration like this, we will be using this relation. Fair? Moreover, this formula can also be written as gamma m plus half, sorry, gamma m plus 1 by 2, gamma n plus 1 by 2 divided by 2 gamma n plus 2 by 2 equals 0 to pi by 2 sine power m theta cos power n theta d theta. So either you remember this formula or this formula. ठीक है, here I have just managed m plus 1 by 2. ठीक है, if you put 2m minus 1 की जगह m, obviously this m will become m plus half, n plus half. So from here I got this formula. So either you can like if you talk about me, I always remember this formula. So whenever you have integrations like this, you can get the integral value just within second. Please note down. And if you have any doubt, please ask. Okay, fair. So please don't forget to remember either of this formula, right? That will be very helpful for us. Just one or two more points, 2 points hardly in the beta function. See, don't think there are infinite number of things, okay? Once you study everything aligned, the life becomes easy, right? Chale. So let's write one more exam point here. Uh, since beta mn is 0 to 1, x raised to the power m minus 1. Okay, dear fellows. What happens if you put x equals 1 upon by? Okay, you getting my point? What happens if you put x equals 1 upon by? So just like randomly we are thinking, okay? If we put x equals to 1 upon by, let's say if we put x equals to 1 upon 1 minus by, you can think of, right? So why I am not directly giving you the formula? Because in many of the integrations you are supposed to have this ability that what substitution can work, which can give the standard form. Suppose that if you put x equals to 1 by y here, right? So what will happen? Obviously m and n mein we have nothing to change. X का value 0, so y will be 1 upon 0, that is infinity. X का value 1, so y will be also 1, right? X is 1 upon y का power m minus 1 into this will become 1 minus 1 upon y का power n minus 1 into dx, right? So that can be written as infinity to 1. Oh, sorry, dx, sorry. So dx will be minus 1 upon y square dy. So this will be minus ka 1 upon y square dy, right? So this will be, this minus can be written here 1 upon y ka power m minus 1 here. This is y ka power 2. So this will be y ka power m plus 1 into this will be y minus 1 ka power n minus 1 divided by का power n minus 1 into dy. So if I change the order of limits of integration, this minus sign can be written as positive. So 1 to infinity, this will become by minus 1 का power n minus 1 divided by का power m plus n, right? This one got cancelled. So what do you have, my dear fellows? अभी देखिएगा, whenever, and please don't take it lightly, okay? If I am saying like this, it means a lot. As a teacher or as an aspirant, I felt this, right? Suppose that you have to integrate some function like this, 1 to infinity by raised to the power by minus 1 ka power n minus 1 upon by ka power m plus n. Then what is the value? If you don't know this relation, your life becomes hell in the exam hall, okay? So please don't ignore this process. I am again saying, you are not supposed to remember everything, but at least this to remember. ये तो remember करना ही है आपको. Okay. So similarly, you can think of for this. Shibu, did you get the point? What I wish to convey here means, in the original definition, some substitutions can work very like in good manner for you. ठीक? So I will write here note, some substitutions used in definition of beta and gamma function can help in finding value of such integrations. Okay, so this is the purpose for giving you this much dealing. Please note down everything. Everything should be at your notes, please. Otherwise, end of the day, when you will sit to revise, everything will be blank. So believe me, whatever I am writing here, that is the experience which I carries over the decade, and things are aligned very much. What to put after what, right? Please note down, everyone. And please do remember, CSE as well as IFOS, in both exams, it is very much important. This procedure, ठीक है? Is that noted? Amit Kadam, where are you, dear fellow? Shantosh, it is noted. Okay, dear. Fair. Chalo. Let's take few questions, few examples to substantiate above exam points. Okay, Let's take few examples here. What they ask? Find the value of 0 to 1 x raised to the power 5 by 2. ठीक है. Suppose that this is the question for you. Okay, camera is being blurred, just wait a minute and everything. ठीक है. And suppose that this is the question for you, right? And you didn't study the beta gamma function. Now please try to do it. Tough, tough na? If you put x equals to sine square theta, again you will end up with some complicated integral, right? So what we need to do in such questions, observe the given integral. ठीक है? The step 1, please do remember this thing. The very important step is this: limits are 0 to 1, functions are x raised to the power 1 minus m into 1 minus x raised to power n type. So this implies what? Beta function. Fair? So in the exam hall or whenever you are practicing such integrations, how to catch? If the integration ka limit is 0 to infinity, exponential term is there, then you will move for gamma function. If limits are 0 to 1 and functions are like this, integrand, then you will go with the help of beta function. I hope it will be clear. If not, please write down at bottom of your page or top of. Chale. So, since 0 to 1 x raised power 5 by 2 can be written as, अच्छा इसको लिख देते हैं एक बार, 5 by 2 into 1 minus x का power 7 by 2. This can be written as x का power 5 by 2 can be written as x का power 7 by 2 minus 1. 1 minus x power 7 by 2 can be written as 9 by 2 minus 1 into dx. So this comes out as beta 7 by 2 comma 9 by 2, beta m comma n. So that is nothing but gamma 7 by 2 gamma 9 by 2 divided by gamma m plus n, 7 by 2 plus 9 by 2. Abhi if you open, gamma 7 by 2 will be 5 by 2 gamma 5 by 2. Gamma 5 by 2 will be 3 by 2 gamma 3 by 2. So if you open this, this will be 5 by 2 into 3 by 2 into 1 by 2 into gamma half. This will be 7 by 2, 5 by 2, 3 by 2, 1 by 2 gamma half divided by gamma 8, right? So gamma 8 ka value what you will write? 7 factorial. Fair? So this will be 5 into 3 into 7, 5 into 3, 5 का square, 3 का square into 7 into pi divided by 3, 3, 6, 7. 2 का power 7 into 7 factorial. If you want to further simplify, you can, otherwise leave it. Did you get the idea? So if you don't use beta function here, it's like next to impossible to find such integrations easily. Okay, so I hope the message is clear, right? Please note down fast, and if you have any doubt you can ask. Let's take me some more examples. If you have noted that question, please come on this. And the second, which I told you, was substitutions, right? So how the substitution can work, please mark star here. And why we have thought like this? Because this does not contain exponential function. So gamma function cannot be used here. Means we'll have to go by the beta function. Baki rest of the things are simpler. So again, this is very important question for your CSC as well as forest services. लिमिट कैसे लिया है भाई? x की जगह 0 पुट करो तो 1 अपॉन 1 प्लस 0 1. सो द लिमिट ऑफ t इज 1. x की जगह इंफिनिटी पुट करो 1 अपॉन इंफिनिटी इज 0. सो t का अपर लिमिट इज 0. शिबू, इफ यू पुट दिस तो dx का वैल्यू भी तो dt के फॉर्म में पुट करना पड़ेगा बच्चे. तो वो माइनस साइन यहाँ पे आ गया. Is that done? अच्छा, अभी वैल्यू यू कैन राइट ना. This is beta function. So this is gamma 1, gamma 4 divided by gamma 5. So gamma 1 का value is 1 into 3 factorial divided by 4 factorial. So that answer is 1 by 4. Right? Fair kingship day. ठीक है. So from the beta function, the last but very important duplication formula they have asked multiple times in your exam. Okay, proof of that. ठीक है. They asked proof. So let's prove the duplication formula. That is the last exam point to remember from the beta function. So that is a PYQ multiple times in civil services as well as forest services. Okay. Sometimes they ask with the name directly or indirectly. So that proof I'll do there. ठीक. Actually वो formula I don't remember. Proof I know. Okay. वो formula थोड़ा complicated है. The reality. Okay. चले. लेट्स राइट दैट डुप्लीकेशन फॉर्मूला यहां पे लिख सकते हैं फेयर 2 raised to the power 2m minus 1 gamma m plus half is square root of pi gamma 2m. ठीक है बच्चे, दिस इज कॉल्ड द डुप्लीकेशन फॉर्मूला, राइट? Although it is not tough to prove, only if you remember the steps. Two steps are there, okay? If you don't remember those two steps, you will, like, it is next to impossible to prove it, okay? If you remember those steps, it is just 1 minute game, not more than that, right? चले, so let's start from there. इसका proof start करते हैं, okay? Since beta mn is 0 to 1 x का power m minus 1, let's write this, okay? Also we have the relation 1 upon 2 beta mn as थीटा का लिमिट 0 टू पाई बाई 2 साइन का पावर 2m माइनस 1 इंटू थीटा कॉस का पावर 2n माइनस 1 इंटू थीटा that we have also done previously, right? So by using this stuff we will try to prove the duplication formula. So what we can have from here, so this implies if I use the same relation, we can have theta equals 0 to pi by 2 sin का पावर p theta cos का पावर q theta as like sin m theta, right? N theta, right? So if I write that as this, so this will be 1 upon beta. अब क्या हो जाता है? p plus half and q plus half, right? चलिए, अभी what we do? Put q equals to p. So we will have theta equals 0 to pi by 2 sin का पावर p थीटा cos का पावर p theta d theta, right? This will become 1 upon 2 beta p plus half and p plus half, right? चले, so this implies we have 0 to pi by 2 sin का पावर p theta cos का पावर p theta d theta equals, if I use this relation here, 1 by 2 gamma p plus half gamma p plus 1 by 2 divided by p plus q plus 2 by 2, right? q क्या है? That is p itself, right? So this relation we have 0 to pi by 2. Abhi just I manage some terms. 1 upon 2 raised to the power p I have taken here. 2 raised to the power p sin power p theta cos power q theta d theta, and that goes to 1 upon 2 gamma p plus 1 by 2 का whole square divided by gamma p plus 1, right? Let's give this as equation number 3. अभी this will become 1 upon 2 का power p 0 से pi by 2 sin 2 theta, right? So 2 raised to the 2 sin theta cos theta is sin 2 theta power p d theta, and this remains same 1 upon 2 gamma p plus 1 by 2 का whole square divided by gamma p plus 1. आप लोग इतना नोट करेंगे, the theory is done. This is 2 theta here, okay? Please don't be confused here. Duplication formula is very easy to prove if you remember the substitutions like this. ठीक है? How to start? Number first thing. How to start? And substitution. ठीक है? These are some keywords to help you. Right? अभी आप लोग इतना नोट कीजिए. I will write further. Please write down fast, everyone. अभी जस्ट p को रिप्लेस करना है एंड वी ऑल हैव डन. cos q थीटा था ना, फिर q को p ले लिया तो cos p थीटा हो गया, cos p थीटा. अब sin थीटा cos थीटा का पावर p, तो मैं उसको sin 2 थीटा आई वांट टू मेक, सो 1 अपॉन 2 पावर p से, मतलब इधर 2 पावर p से डिवीजन कर दिया, 2 पावर p से मल्टीप्लाई कर दिया. दिस एक्सप्रेशन टर्न्स आउट टू बी sin 2 थीटा, उसका पावर p, दिस इज p, सॉरी. ओके शिबू. इसकी जगह इसको नंबर दे देंगे, दिस इज नंबर 3. ओके, अभी देखिएगा, आई वॉन्ट टू सॉल्व दिस इंटीग्रेशन, दिस लेफ्ट हैंड साइड. ओके शिबू, सिंस LHS of 3 is 1 upon 2 raised to the power p, theta going from 0 to pi by 2, sine ka power p 2 theta d theta. So put 2 theta equals t. This implies 2 d theta equals dt. So this will become 1 upon 2 raised to the power p. D theta is dt by 2, so that is 1 by 2 here. Theta is 0 से pi हो जाएगा. Sin p t dt, right? So if you use the property of definite integral, what will happen? This will be 0 से pi by 2 two times, right? This will be 2 times 0 से pi by 2 sin pt dt, right? What? Wow, what I have used? Since 0 से 2a f of x dx is 2 times 0 to a f of x dx if f of 2a minus x equals f of x. This is the property we have already learned in the previous lectures. So what do you have, dear fellows? 1 upon 2 raised to the power p minus 1. So that is p minus 2, right? 0 से pi by 2 sin pt. अभी 0 से pi by 2 is the limit. So what you can write here? Sin m x, sin m theta, sin cos n theta. एक बार मैं लिख देता हूं, 0 से pi by 2, right? This can be written as sin pt into cos 0t, cos power 0, किसी का power 0 is 1, right? Finite value. So what do you have, dear fellows, from here? 1 upon 2 raised to the power p minus 2 into what I told you previously. This will become gamma p plus 1 by 2, gamma 0 plus 1 by 2 divided by 2 gamma p plus 0 plus 2 by 2. Is that clear to you all? So what will happen? This will come out as 1 upon 2 का पावर p माइनस 1, एक 2 यहां से जाएगा, ठीक है, इनटू गामा p प्लस 1 बाई 2. गामा हाफ का वैल्यू इज स्क्वायर रूट ऑफ पाई डिवाइडेड बाई गामा p प्लस 2 बाई 2. गामा p प्लस 2 बाई 2. Let's say this, you give this as 4. अभी क्या है, we will use in place of this the value as this. Okay, please note down. Check it out please. बस you are done. अभी इस रिप्लेसमेंट करेंगे, we will get the duplication formula. Please write down. This is another important substitution here. Please note it down आराम से. And duplication formula में what are the substitutions? Number first is beta mn का sin cos वाला फॉर्म, right? sin cos वाले फॉर्म में taking, अगर आप पी क्यू लिख रहे हैं, if you are writing p and q then take p equals to q. If you are writing m and n, take m equals to n, right? After solving that thing, don't forget what we have to substitute. So if you don't remember this substitution, believe me, you will feel the fever in the exam hall for sure. I have done my job. I have clearly stated what to remember out of this duplication formula, because in the exam hall, definitely such questions you will have. Is that clear to you all? फटाफट इसको नोट करेंगे, नोट डाउन फास्ट. Shundram, Duplication formula is clear or not? Please look over your copy. Noted? Fair? Chalo Shibu. So Shantosh, Kunshuk Day, everyone, Amit, everyone. So now you people are supposed to remember how to prove duplication formula. If you don't remember this, thoda bahut to, like little bit you should have idea. Fair, 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 fair. Very good, very good. So duplication formula, why I am again and again saying, because definitely they ask such proofs in the beta function. No one has expected when they ask first time. So please don't ignore such proofs. Very easy, but only point to notice is how to start and what are the substitutions. ठीक है? चलिए. So this is all about the beta function. Now, what we people are supposed to do is, we have started from the lecture 1. It was just basic integrations, right? Integration of 1 upon under root x square plus a square, integration of under root a square plus x square, how you can take 1 into then integration by parts, where the partial fractions can work. This was all about the lecture 1. So what you are supposed to do, whatever integrations as an example we have done in the exam lecture 1, please note down all those final formulas at one place and keep revising that, because if you don't remember those formulas in the mains exam hall, you will be wasting your time, precious time. ठीक है? In the lecture 2 we have learnt about properties of finite integral, right? Then we learnt about Leibniz rule as well. Fair? Then today we have learnt about beta gamma function. So what I told you, the box 1, right? When I discussed about the lecture plan, so lecture plan mein the first box was simple integrations, finite and infinite, with beta gamma function. So that I have done here. Now what you are supposed to do, there is a pyqs ka file, okay, that I have provided in the Telegram group itself. I have compiled all pyqs chapter wise in two papers, paper 1 and paper 2. So paper 1 contains the whole book, right? So if you don't have that book, please ask in the Telegram group, you will get that. So in that integral calculus का जो chapter है, वहां के PYQs if you will look for, just wait a minute, I have those PYQs. Just wait a minute. Open. ठीक है. In that file, page number 35, 36, page number 36, PYQ file, booklet it is, okay? पेज नंबर पेपर 1 का PYQ फाइल, ओके? पेज नंबर 36, इंटीग्रल कैलकुलस. नंबर फर्स्ट इज इंटीग्रल by summation, limit of summation, which we have done in the previous lecture, okay? Two questions they have asked to 2018 and 2012 CSE. Then definite integrals, the lecture 2, right? Definite integrals lecture 2, uske PYQs all are aligned here. Then beta and gamma function ke PYQs are aligned here. So what you people are supposed to do today is trying at least, not doing, trying these three chapters ke PYQs. Okay? Because in the next lecture, I will come and will discuss about these PYQs. If you haven't solved or if you have any doubt, do let me know. Then we will move on the next chapter, that is single integrations for area and volume and all. Okay? So the first segment is done for integral calculus. You are supposed to do try at least for PYQs of this chapter. Okay? Page number 36, paper 1 ka integral calculus PYQs file. Okay? If you have any doubt, you can ask over my number 9971030052. So it's enough for the day. We will meet by. अच्छा, आप लोग ऐसा नहीं बोलेंगे सर, यू आर बिहेविंग लाइक अ पॉलिटिशियन. I yesterday said na, if possible, I will take 3 hour session. Otherwise, it is like okay. We have done a lot today, so it is just one session for today. Chick, Shibu, don't be angry, है ना? Leave on me, na. The syllabus will be over with time because I know where to put, है ना? What to touch here. Chalo, good luck everyone. If you have any doubt, do let me know. So it's enough for the day, okay? Okay, Shivu, no problem. I said ना, whatever I have promised, I will fulfill for sure. बट अभी क्या ना थोड़ा फंक्शन है, सम हाउ आई एम ट्राइंग टू मैनेज कि क्लास बंक ना हो बस, है ना? चलो, हैव अ गुड डे, बाय बाय.